Welcome to lesson 5.2, functions continued. Let's take a look at the bell ringer. So it says complete the function table below by filling in the missing values of y. So as we go from 8 to 5, it looks like we're decreasing by 3, which is the same as going from 11 to 8, we're decreasing by 3. So if we continue this pattern of decreasing by 3, we have a y value of 2 and a y value of -1. So now we have to figure out what our slope is. Remember, our slope is our change in y over the change in x. So my slope is going to be my change in y. It's changing by -3 each time. And my change in x, well, each time it's getting 1 larger. So it's going to be a 1 down here. So that means that my slope is -3. So when I write this in my y-intercept form, I have y equals -3x plus my y-intercept of 2, because when x is 0, y is 2. So what is the initial value of the function? Well, I start at y equals 2. My slope is -3. And find the output value. If the input is 10, that means my x value is 10. So when x equals 10, it's going to be y equals -3 times 10 plus 2, which is -30 plus 2, which is -28. Sorry, -28. Okay, so let's look at our notes for today. Our objective is to define domain and range of a function and determine if a relation is a function or not. Figure out what a function is. Well, a function is a relation where every input has exactly one output. So what that means is that every x has exactly one y that it's mapped to. You can't have an x being mapped to 2 different y's, then it's not going to be a function. So a domain is the set of all possible inputs, values that we have, and our range is the set of all, you guessed it, outputs. And our outputs are our y values. So a function has every x value maps or corresponds directly to one y, never anymore. The domain is a set of all x values that are in our table or our graph, and the range is a set of all y values or outputs. Go ahead and flip the page. All right, so let's take a look at this table right here. What is a domain? Well, the domain is the set of all inputs or the set of all x values. So it's going to be the set, make sure you put set notation, of 2, 3, and 4. Right? Those are all of my inputs, all of my x values. So what are my input values? Those are the same as my domain. It's going to be 2, 3, and 4. Now I have my range. My range is values. So all of my possible y values that I have here are 5, 7, and 9. So what are my outputs? That means when I plug in 2, I get 5. Plug in 3, I get 7. So my outputs are all of my y values, which are, again, 5, 7, and 9. Okay? All right, let's take a look at number 1 now. Number 1, we have to name the domain of the relation. So remember, the domain is all of the x values in our set. So I have the set, my first x value, right, because this is my ordered pair x, y. My first x value is -4. My next x value is 4, 5, and 6. So that's my domain, my set of all x values. And my range, well, that would be the set of all outputs, set of all y's. So I have 3, 9, 12, and 9 again. Now, is it okay to repeat 9? Absolutely. All right, now what I would like you to do is take a moment to do 3 and 4. Find the domain and the range of both. When you're done, please raise your hand to get it checked by the teacher. Go ahead, pause the video, and do 3 and 4. Go. All right, welcome back. Let's take a look at 6. Hopefully you rocked 3 and 4. So 6 says, is the following relation a function? Why or why not? So remember, a function has every x value has exactly one y value. So if I look here, I have an x value of 1, an x value of 2, 3, and 4. X value is the same? No. So I don't have to worry about the mapping to something different, right? So yes, it is a function because every input, every x value has exactly one output or y value to match to it. Okay, now looking at number 7, is the following relation a function? Why or why not? So function, again, is if the x value maps to something more than one item. So I have 0, 2, 4, and 4. Uh-oh, my two x values here are repeating. I have 4 twice. 4 goes to 3, and 4 goes to 5. So if this was in a table, I'd have 4 goes to 3, and 4 goes to 5. I can't have 4 going to 2 separate outputs in a function. So is it a function? Absolutely not. It is not a function because 4 has 2 different outputs. One is 3, the other is 5. Okay? So if the x value is repeated, it needs to go to the same exact y as it did before. Otherwise, it is not a function. Okay? So go ahead and flip the page. Now you're working on 8, all 1, 2, 3, 4, 5 parts. All 5 parts. When you're working on 8, please make sure that you check to say if it, like this one, for example, says it's not a function. This one says not as well, but this one says which one represents a function. So read them carefully. I want you to do 8 this entire page. When you're done, please get it checked by the teacher. Go ahead, pause the video, do it right now. Go. All right, welcome back. I'm flipping the page. We're looking at this very next one. So this top one says, given the relation, and we have a set of ordered pairs here, which replacement for A makes it a function? So that means that my A should be different than all of my other x values. So I already have a 1. So if I put a 1 here, 1 would map to 4 and 9. Nah, don't want that. If I have -2 here, then that means -2 would map to 4, but -2 also maps to 3. Nope, can't have that. Next one, if we have a 0 for A, 0 would go with 4, and 0 would also go with 7. 0 can't go to 2 different things. Sorry. So now I have 4. Let's see. -2, A, 1, 0, 4 could absolutely work. Okay? All right, now what I would like you to do is take a moment to pause the video, do these 3 problems. 1, 2, 3. 1, 2, 3. All right, go ahead, pause the video. Get it checked when you're done. Okay. All right, welcome back. Let's take a look at the last one on this page. It says the function f has a domain of 1, 3, 5, 7, and 7, and a range of 2, 4, 6. Be represented by the set of ordered pairs. Well, let's see. 1 maps to 2 and nothing else. 3 maps to 4 and nothing else. 5 maps to 6 and nothing else. 7 maps to 2 and nothing else. I do notice that there's a 2 here and a 2 here, though. So my y values repeat. But remember, you only care about the x values repeating and making sure that they don't go to 2 different things. The y values can repeat. That is okay. When the y values repeat, that just means you're going to have 2 points that when you connect them make a horizontal line. Okay? So is it a function? Yes, it is. Because every has exactly one output. Okay? Doesn't matter if we have 2 outputs that are the same as long as the inputs are different. Okay? All right, flip the page. Let's take a look at the vertical line test. All right, vertical line test is super cool. I love it. So since relations and functions are set of ordered pairs, they can be graphed, right? Of course, Miss Wall. Hello. So let's graph these. So my first point is 1, 2. My next point is 2, 2. 4, 2. And 4, 1, 2, 3, 4, 5. Right up here. So I'm going to connect those points. And then because it's a relation, I'm going to connect the dots. And I make kind of like a backwards L shape in a way. So it says using the vertical line test is the relation a function. So a function can't have any inputs. So looking just at our picture right here, we have 4 goes to 2 and 4 goes to 5. So we know it's not a function. And how we can test with the vertical line test is looking to see if anywhere on the graph, anywhere on the function, there is possible function, remember, might not be a function. I can draw a line and have it only touch the graph once. So every time I draw a vertical line, if it only touches the graph once, then it is a function. If I draw a vertical line like this one, this is right on my relation, right? Then it does not pass the vertical line test. So if there are any vertical lines that you can draw that passes through your relation more than once, it is not a function. So is this a function? No, because this line passes through points on the graph more than once. Okay, so let's take a look at these bottom ones below together. So this first one says, which graph represents a function? So let's look at the first one, vertical line test. Boop, 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 boop. Anywhere I draw a vertical line, it passes through this oval twice. So that is not a function. Well, my gosh, Dolly, I draw a vertical line on top of that. It hits every point, so that's not function. Here, if I draw a line here or here, here it doesn't seem to go through on this last one, but the middle one does. So as long as it's somewhere on the relation, then you know it's not a function because it passes through twice. This last one, no matter where I draw my line, it will only pass through my equation once, so I know that my last one is a function. Okay? Now, looking at the next one, it says which one does not represent a function. Well, that means we're going to have to check out our vertical line test. And what do you know? Flat down, it hits it more than once, right? So that's a contender. Here, with my horizontal line, if I draw vertical lines, I'll never cross a horizontal line more than once. Same thing with this decreasing line and this increasing line. No matter how many times I draw a vertical line, it will only cross it once. So that means 1 is not a function. Make sure you read carefully, okay? Last one. Which statement is true about the relation shown on the graph below? So it is a function. It is a function. It's not a function. It's not a function. Let's see. Vertical line test. Zoop, zoop. Oh no, it passes through twice. It's not a function. So I can immediately eliminate 1 and 2. So I'm left with, it is not a function because there are multiple y values for a given x value. My x value, I have a y value at 0 and I have a y value way up here. And that is true, which means my answer is 3. All right, go ahead and flip the page. Almost done. All right. On this page, I want you to go ahead and do these 3 multiple choice problems. Please read the directions carefully to say whether it's a function or not. And when you're done working on these 3, please raise your hand to get them checked by the teacher, and then you can start your homework. All right, have fun. Bye.